Hello, my dear students. Today we are going to discuss the NCERT text problem in example 3.6, figure 3.23, page 116, the skeletal cube diagram problem. First of all, here it is given a cell which is having an EMF 10 volt and it is indicated by a position E. Okay, it is also EMF also and position also, and which gives a current 3I which is going over the point A, which is splitted into three parts. These three parts will further go into the point A to A dash, A to D, and A to B section. So this current over here will split into, from A dash it will split into half and half, I by 2, I by 2. From D it will split into half, half, and at B also it will split into half. But after a certain time, this from D part now, there will emerge a current I. Why? Because this half from this section and half from this section will join together to form the full I. And from B also there is a current evolving I. That means the half current from the B and half current from the A dash will join together to form I. And what is from C? There is also an I, which is formed by the half current from the B section and the half current from the D section. So all these half, that means half and half will give I from the D, and this half and this half will give I from the D, and this half and this half will give I from the C section. So these 3I again will join to give the initial current 3I. So this is an example of the first law which we have discussed in the earlier classes in the PCM Guru Bro. First of all, the current 3I is split into three parts, and again these three parts will join together from the main current. So at any point in a complicated electrical circuit junction, the total current inward is equal to total current outward. That means the algebraic sum of the current will be 0. So 3I given and 3I out, 3I in, 3I out. Okay, the circuit is complete. This is not a real problem. This is just to explain what is in it. Here it is given resistance. This is 1 ohm each. Each resistance which you see now red colored, each resistance is 1 ohm each. It is all connected to the edge of this cube. It is a cubical structure, and this edge, the whole electrical lines now is joined in a form like a cube, and the geometrically opposite points now A and the backward C dash. Consider, I will make it easy for you. This A, B, C, D is the bottom plane, and A dash, B dash, C dash, D dash is the top plane. So this thing, first of all, the geometrically opposite points A and C are joined together to this cell. So if R is 1 ohm, then what will be the current in it? That's the problem. So first of all, we will take the current equal. Now the I current are same over here. So A dash is equal to AD is equal to AB. This is the basic thing. So taking a loop, A, B, C, C dash EA. A, B, C, C dash EA. That means this thing. A, B, C, C dash E, A. Along this section, look at this. In the text it is given IR plus I by 2. Okay, IR, I into the resistance R ohm into I by 2. This section, AB section IR, BC section I by 2, and CC dash section I is equal to this given 10 volt. By earlier classes which I have taught you, just take the water roll. If the circuit is starting from the cell in the positive section, positive terminal, then we should give it a positive sign over here, and the starting current conventionally we will take it as negative sign. It is given in the NCERT text example which I have given you in the earlier YouTube classes in the PCM Guru Bro channel. So sign convention is clear now, because when it starts from positive point, give the positive sign and take the current to be negative. It will clear out. Look, this is the main thing you have to learn and write it like this. This current, this I, look at all these things. This minus things, when it go to the other side now, will give this equation. So it is clear now. But by now we learn this, and we can follow what is given in the text and further proceed. Learn this very well. I have taught you when it is from the positive terminal of the battery, positive, and give the current sign as negative, and make it easy for yourself. Then from the first equation, this is now IR plus 1 by 2R plus IR is equal to 10 volt, which is given by, we will make the denominator same, so that add all these rational numbers now. So 2 by 2, 2 by 2, multiply the whole numerator and denominator by 2 by 2. This also numerator and denominator multiply by 2 by 2. Then, okay, denominator are same. So then 5 plus 1 plus 2. 2 plus 1 plus 2, 5 IR by the same denominator 2. 5 IR by 2 is equal to 10 volt. This is okay. We can make it simplified over here. That means the EMF is equal to 10 volt is equal to, that means the battery's EMF is equal to 5 by 2 IR. That means this EMF is the same as the current into resistance connection. We know the basic equation. V is equal to IR. V is equal to IR. That's it. The EMF provides the same potential difference over here. Potential difference is given by the EMF. Okay. So we will first of all, we do not know what is all when we calculate what are all resistance over here. What will be the equivalent resistance? We do not know. No. So we will denote an equivalent resistance by the symbol R equivalent resistance of this whole network. So this epsilon is equal to 3I. What is all the total current? 3I into the equivalent resistance. That means the potential difference over here. So it is similar to this equation. No? V is equal to IR. 3I is the current and R equivalent is the total resistance of the circuit. So look over here. This epsilon I wrote it as 3I into R equation. No, this R equation we will put in this side, and this 3I will get to the denominator of epsilon. Okay, R equivalent is equal to the EMF by 3I. EMF by 3I. Then R equivalent is equal to the EMF we got. No, that means 5 by 2 IR. This thing now we will put over here. So the R equivalent is equal to 5 by 2 IR by 3I. This I get cancelled, and what will be left? 5 by 2 by 3. That means 5 by 2 by 3 is equal to 5 by 2 into 5 by 2 into 1 by 3. When we divide two fraction numbers, no, then first of all write this same number and multiply by the reciprocal. That's it. So we will get the R equivalent is equal to 5 by 6 R. So here it is resistance is 1 ohm each, no. So that resistance is multiplied over here. That means 5 by 6 into 1 ohm. That means 10 volt is equal to 3I into 5 by 6 ohm. This is over here. That means the voltage is equal to current into resistances. Always look into the similarity of what are all fundamental equations we have. Then here we want to find the current, no? So simplifying this equation, 10 volt by 5 by 6, the whole thing gets into the denominator. 10 by 1 into 6 by 5, that is 3I. 60 by 5, that means 10 into 6. 60 by 5 is equal to 3I. 60 by 5 is equal to 12 by 60 by 5 is equal to 12 is equal to 3I, the same thing. And I is equal to 12 by 3, that is 4 ampere. So after this, you find all the current yourself in this diagram. This is finished. Practice well.